A reverse proxy is a server that sits in front of your backend services and forwards client requests on their behalf. From the client's point of view, the proxy is the origin server. The backends behind it stay invisible. This is the opposite of a forward proxy. A forward proxy sits in front of clients, hiding them from the internet. A reverse proxy sits in front of servers, hiding them from clients. The flow runs. Clients connect to the reverse proxy, and the reverse proxy fans the request out to backend A, backend B, or backend C. The reverse proxy sits in the middle for three powerful reasons. It gives you a single ingress point, so clients always hit the same address. It hides your internal topology, so attackers cannot enumerate your real servers. And it abstracts your infrastructure, so you can add, remove, or move backends without clients ever knowing. Use case 1. TLS termination. The proxy handles all HTTPS traffic, decrypts the request once at the edge, and forwards plain HTTP to your backends. This offloads the expensive cryptographic work from your application servers and lets them focus on running your business logic. Use case 2 caching. The proxy stores copies of responses for requests it has seen before. When the same request comes in again, the proxy answers directly without waking up the backend. The result is lower latency for users and less load on your application servers. Use case 3. Load balancing. The proxy distributes incoming requests across multiple backend instances, so no single server gets overwhelmed. Common strategies include round robin, which cycles through backends in order, least connections, which sends traffic to the least busy server, and IP hash, which sticks a client to the same backend based on their address. The canonical reverse proxy in production is Nginx. It's lightweight, battle-tested, and built specifically for high-performance request routing. Most of the time when teams say reverse proxy, they mean Nginx. The workhorse directive is proxy_pass. You place it inside a location block, and Nginx forwards any matching request to the upstream URL you specify. A minimal example is proxy_pass http /127.0.0.1:8081. That single line tells Nginx to hand every matching request off to a backend listening on that address. For load balancing, you define an upstream block, a named group of backend servers. Inside, you list each server line by line. Then your proxy_pass references the upstream by name, and Nginx distributes traffic across the group automatically. Putting it all together, the client connects to Nginx on port 80. Nginx matches the request against its location blocks. It applies proxy_pass to forward the request to the right upstream. The backend generates a response, and Nginx returns that response back to the client. The backend never touches the client directly. And that's the entire point of a reverse proxy. Welcome to a quick terminal walkthrough. We'll spin up a simple Python static backend on port 8081, confirm an existing Nginx server is healthy on port 80, and preview how a proxy_pass directive would route traffic between them. The two endpoints we're about to inspect are exactly the ones a reverse proxy needs to bridge. We start by clearing the terminal so the upcoming command output is easy to read. The clear command simply scrolls the visible area, leaving the cursor at the top of a blank canvas. Now we launch a Python HTTP server in the background, serving the /tmp directory on port 8081. The ampersand detaches the process so the prompt returns immediately, and we can keep working. With the server up, we send a head request to confirm it's actually listening on 8081. The HTTP 200 OK response confirms the static backend is live and reachable on the loopback address. Before touching Nginx, we check its installed version. This tells us which build is on the box. Useful when you later write a proxy_pass block, since directive syntax can vary slightly across versions. Next we run Nginx in test mode to validate the existing configuration without actually reloading the service. The syntax is okay, and test is successful. Lines mean Nginx is happy with its current config, a safe baseline before any proxy_pass edits. Now we hit Nginx on port 80 with a head request to confirm the front-end server is actually serving traffic. The server header reveals Nginx, and http:/1.1200 OK tells us the default site is healthy and ready to be pointed at our Python backend. Finally, we confirm the Python process is still running by grepping ps for http.server. The job ID matches the 14821 we saw earlier, proving the backend on 8081 is alive. With port 8081 serving static files and port 80 serving Nginx, you now have both endpoints in place. A proxy_pass directive like proxy_pass http //127.0.0.1:8081 inside a Nginx location block is what bridges them.